about the Francis turbine problem. So the question is, the following data is given for a Francis turbine. Net head H equal to 60 meters. Speed of the turbine is 700 rotations per minute. Shaft power equal to 294.3 kilowatts. Overall efficiency equal to 84%. Hydraulic efficiency is 93%. Flow ratio is given as 0.20 and breadth ratio N is 0.1. Outer diameter of the runner is equal to 2 times the inner diameter of the runner. Thickness of the vanes occupy 5% of the circumferential area of the runner. Velocity of the flow is constant at the inlet and outlet, and the discharge is radial at the outlet. From these given data, determine guide blade angle. Number 2, runner vane angles at inlet and outlet. Number 3, diameters of the runner at the inlet and outlet. Number 4, width of the wheel at the inlet. These are the data given in the question. From this, we have to determine the guide blade angle, runner vane angles, diameter of the runners at the inlet and outlet, and width of the inlet and outlet. So we will see step by step procedure to solve this problem. So the given data, as we know, the net head H equal to 60 meters, speed 700 rotations per minute, shaft power it is 294.3 kilowatts. Overall efficiency is 84%. We know that overall efficiency eta naught is equal to shaft power by water power. Hydraulic efficiency eta H is equal to 93% is given. We know the hydraulic efficiency eta H equal to VW1 U1 divided by GH. Next, the flow ratio is given as 0.20. So we know velocity of the flow at the inlet will be equal to the ratio, flow ratio into root 2GH. Therefore, Vf1 by root 2GH equal to 0.20. From this relation, we can calculate the value of V1. So, Vf1 equal to 0.2 into root of 2 into G, that is 9.81 into head 60 meters. Substituting all the values, we can get velocity flow at the inlet, that is Vf1 equal to 6.862 meter per second. Next, the given is breadth ratio, that is 0.1. So breadth ratio means it is V1 by D1, which is equal to 0.1. Outlet diameter is given as 2 times the inner diameter, that is D1 equal to 2 into D2. Velocity of the flow, that is we have calculated Vf1 equal to Vf2 equal to 6.862 meter per second. Since it is given in the question, velocity of the flow is constant at inlet and outlet. So Vf1 will be equal to Vf2. Next is given as thickness of the vanes is equal to 5% of the circumferential area of the runner. So the actual area of flow will be the 100 minus 5%, that is 95% of the total area. So actual area of the flow is equal to 0.95 times pi d1 into v1. So discharge at the outlet is given as radial, hence VW2 from the velocity triangle, VW2 will be equal to 0, and VF2, that is velocity of the flow at the outlet, will be equal to V2. From the relation, we know that overall efficiency equal to shaft power by water power. We can calculate the total discharge of the water. So that is eta naught equal to shaft power, that is 294.3 kilowatts divided by rho GQH by 1000. Substituting the known values, that is eta naught is known, shaft power we know, rho is 1000, G is 9.81 and Q we have to determine, and H is 60 meters. So substituting all these values, we can find Q, that is it is determined that Q is equal to 0.5952 meter cube per second. And we know that Q is equal to, for a Francis turbine, we know that Q equal to actual area of the flow into velocity of the flow, that is from quadratic equation. Q equal to that is actual area of the flow, we have assumed it is to be 0.95% of pi d1 v1 into vf1. So we know Q and we don't know D and B, so we have to calculate the d1 and v1, but we have taken the breadth ratio d1 by v1 to be 0.1, it is given in the question. Hence for v1 we can calculate it as v1 by d1 equal to 0.1, hence v1 will be equal to 0.1 times d1. Substituting the known values, that is instead of v1 it is 0.d1, so we will arrive d1 to be 0.54 meters. So but v1 by d1 equal to 0.1, substituting the value of d1, we can arrive v1 equal to 0.054 meters. So this we have calculated from the discharge, that is from current equation. Next, the tangential speed of the runner at the inlet, that is we know the tangential speed u equal to pi dn by 60, that is u1 equal to pi d1 n1 by 60. which is equal to pi into d1, it is we have calculated, that is 0.54 into n, it is 700 rotations per minute divided by 60. Substituting the values, calculating, it is u1 is to be 19.79 meter per second. And from the relation we know the hydraulic efficiency eta h equal to Vw1 into u1 by gh. So substituting the known values, that is eta h, u1 we have calculated just now, divided by g, that is 9.81 into h60, we can arrive Vw1 equal to 27.66 meter per second. So now we have calculated all the known values. First in the question they have asked to determine the guide blade angle alpha. That is, from the velocity triangle we know that guide blade angle alpha will be equal to, that is tan alpha equal to Vf1 by Vw1. We have calculated the values of V1 and Vw1. So substituting the values of Vf1, that is velocity flow at the inlet, and Vw1 just now we have calculated to be 27.66, alpha equal to tan inverse of Vf1 by Vw1, hence resulting in alpha equal to 13.928 degrees. Next is then question they have asked to determine the runner vane angles at the inlet and outlet, that is theta and phi. So from the velocity triangle we know that tan theta will be equal to Vf1 by Vw1 minus u1. Substituting all the values we can get that theta equal to tan inverse of Vf1 by Vw1 minus u1, resulting in theta equal to 41 degree 5.4 seconds. Next from that is we have to calculate the runner vane angle at the outlet, that is phi. So we know that tan phi will be equal to Vf1 by tan phi equal to Vf1 by u2. So we have to calculate u2, since we know the tangential speed u2 is given by pi d2 into n by 60, and in the question it is given that in the question it is given that outer diameter d1 equal to 2 times the inner diameter, so d2 will be equal to d1 by 2. So substituting the values of pi into d2 equal to d1 by 2 into n by 60, we have calculated d1. Substituting all the known values, we can calculate u2, which is equal to 9.896. Now again substituting in tan phi, that is equal to Vf2 by u2, so phi equal to tan inverse of Vf2 by u2, resulting in 34 degrees 44.4 seconds. The two questions we have, that is we have calculated the guide blade angle, and then we have calculated the runner vane angle at the inlet and the outlet, that is tan theta and phi. Theta equal to tan inverse of Vf1 by Vw1 minus u1, and tan phi, that is equal to 6. That is Vf2 by u2. u2 we have calculated from the tangential velocity, that is u2 equal to pi d2 n by 60. D, which is given as d1 is equal to 2 times of d2, hence d2 will be equal to half of d1, that is d1 by 2. Substituting the value of u2 in tan phi, we can get phi equal to tan inverse of Vf1 by u2, which is equal to 34.44 seconds. Already the third question asks the diameter of the runner at inlet and outlet, that is d1 and d2. So we have calculated both the values, that is we know d1 is 0.54 meters, hence d2 will be equal to half of d1, so that is 0.27 meters. Next is the width of the wheel at the inlet, that is we have calculated it is 2b, since we have given us the breadth ratio is given, that is v1 by d1 equal to 0.1, hence v1 is equal to d1 into 0.1, that is 0.054 meters, that will be equal to 5.4 centimeters. So from this we have known to calculate the guide blade angle, runner vane angles, diameters of the runner at the inlet and outlet, and width of the wheel at the inlet. We have calculated all the details, and we have determined all the from the known values of flow ratio, breadth ratio, and hydraulic efficiency, and from the overall efficiency. So this is we have all calculated all these things. From this it is over. Thank you.